So I don't know where we have stopped last time. We were talking about stereochemistry. Stereochemistry of or mechanism of SN2 reactions. Am I right? Is this what we were talking last time? I think now SN2 reaction. I have given you the structure. This is H, H, and H, and Cl. I take OH minus. This is my nucleophile. I have 3 pair of electrons, and this pair of electron will oh, what is this? This pair of electron will attack from the back side, and see this. Now what will happen is this carbon will become a weak bond here. The OH will form a weak bond from the other side. The carbon will become straight. That is what you have to remember. And I will get like this. This becomes straight. And my Cl is on the leaving side. So you have a pentavalent transition state. A pentavalent transition state. A pentavalent transition state. And this, now the leaving group completely goes off, and your OH is getting totally attached to the carbon. You have the hydrogen here, and you can see here the hydrogen is getting bent to the opposite side. And you get this compound. And yesterday we have seen if you take an optically active compound, see here, I take this compound with the H here, C2H5 here, and a chlorine, and then react this with OH minus, I will get this product. OH, I'm sorry, H, one second, let me, CH3, oh sorry, too many mistakes. See here, the CH3 will be on the back side, C2H5 is on the front side, and I have got my OH here. Okay, and see, that is what we have stopped yesterday. I asked you to find out whether what is the configuration here. This is 1, this is 2, and this is 3. That is the order of what is that? A priority order. Now what we should do? This is 4. We have to bring the hydrogen to the back side. That means I have to bring the hydrogen to the place of CH3 to the place of C2H5, and C2H5 to the place of hydrogen. So I will get this molecule is the same as this one. So you can write this. So let me take the C2H5 up, C2H5. Then to the back I have got the hydrogen. To the front I have got the CH3. And I got the Cl here. And remember what is the configuration of this? The order is 1, 2, and 3. So this is having an R configuration, and the same way you find out the configuration of this compound is found to be S configuration. Okay, now what has happened is R has become S, or you can see from here it has got inverted, and if your starting material is S, it will become R. So the configuration of the molecule changes. Okay, this invert, it gets not only changes, get inverts. Molecule get inverted. The configuration of molecule is inverted. I use that word. Inverted. So this is what is called a Walden inversion. Walden inversion. So these are the methods by which you can find out whether a compound is SN2 if a Walden inversion has occurred in a substitution reaction. In a substitution reaction, if there are different conditions. If number one, if the rate is proportional to, its rate is changing when the concentration of nucleophile and substrate are changed. Then number two, if the product is having opposite configuration of that of reactant. If the product is having opposite configuration of that of the reactant, then the reaction follow SN2 mechanism. Okay, now let us see what is the energy, how is the energy change occurring in the molecule. So we will see energy profile diagram. Energy profile diagram of the molecule, of the reaction. Okay, how does the energy changes in the molecule with time? So you are starting the reaction, your starting material is having an energy. This is the energy level of the starting reactant. Okay, now the energy increases. It goes to the top and then it comes down. And here is a product. And this is the energy of the product. Energy of product. So this is progress of reaction time. progress of reaction, and this is energy delta E. And now see here this, so overall delta H, this is the delta H of the reaction. And what about this? What is this? This is activation energy delta E. Okay, so this is overall, and you have remember this is a transition state, energy of the transition state, and there is no intermediate in this reaction. No intermediate in the reaction. Okay, and therefore there is no only one step, a transition state and the product. So reaction is, it's a single step reaction. It is a single step reaction. Okay, now, so that these are the, now let us see what type of, what are the different factors which affect the SN2 reactions. Okay, factors that affect this SN2 reaction. Now, let us see. Let us look at this. Look at this structure of substrate. In the case of substrate, one second, let me take the board up. Yeah, factors that affect SN2 reaction. Okay, we will consider the case of substrates. Number one, substrate. Substrate. In the case of substrate, primary alkyl halide. Primary alkyl halide reacts faster than secondary tertiary. That is, we have seen CH3Cl when reacted with water, with the sodium hydroxide, NaOH, you will get CH3OH. Okay, but if you are taking an alkyl halide, which is tertiary butyl chloride, CH3, CH3, reacting with sodium hydroxide, you will get very small amount of tertiary butanol. Very small amount. Okay, what is the reason for that? The reason is, see here, OH has to come to the from different backside. The OH has to come from the backside. Am I right? That is what we have seen last time in the mechanism. This has to come from the backside and it has to reach this carbon. But unfortunately, you have so many hydrogens here, which will prevent the entry of the OH. Okay, so approach, it's the nucleophile cannot approach from the opposite side. From the opposite side. Nucleophile cannot approach from the opposite side. because of steric reasons, because of crowding, because of crowding due to bulky alkyl groups. Bulky alkyl groups. So this is the reason why the SN2 reaction will not occur for tertiary alkyl halides. So as far as substrate is concerned, primary alkyl halide will undergo SN2 reaction. Secondary will undergo SN2 or SN1, depending on other factors. And tertiary will undergo SN1 substitution. Okay, so this is the order of reactivity for SN2, right? Tertiary substrates are least reactive under SN2 condition. Now let us look at second number two. Number two, the nature of nucleophile. Nature of nucleophile. How does the nature of nucleophile? Remember, we have classified the nucleophiles into different types. What are the different nucleophiles? Nucleophile. How does the nucleophile structure affect nature of nucleophile? You have strong nucleophiles. Strong nucleophiles. Okay. Strong nucleophiles react faster in SN2 mechanism. Why? Why strong nucleophiles are faster? Because removal of leaving group okay, 10 more minutes. Removal of leaving group is not easy. We have seen that it is getting removed from over a period of time. The leaving group is not just going off. A strong nucleophile has to push it. A pushing is required. A pushing is required from the backside. Pushing is needed. Now remember, why it is not leaving? Why the leaving group is not leaving fast? See here, look at this mechanism, CH3Cl. Suppose the leaving group is leaving first. What you will get is CH3 plus Cl minus. Suppose this is occurring, right? This is not stable. Not stable. Okay, so this is not stable. So since an unstable nucleophile is formed, this will not, therefore this will not occur. Okay, this will not occur. And that is why the leaving group will not leave fast in this type of from this type of alkyl halide. From primary alkyl halide, the leaving group will not move away fast because the resulting carbocation is not stable. And so a pushing is needed, which can be done only by strong nucleophile. So this is the effect of nucleophile on the SN2 reaction. Next, effect of leaving group. Now, what are the different leaving groups? Cl, OH, SO3H, SO2R. Okay, all these are Br, COOCH3, OCOCH3, sorry, OCOCH3. All these are good, our leaving groups. Now, leaving group, normally in SN2 reaction, any of the leaving group will work. Okay, good leaving group or bad leaving group, both will not have much of an effect. They all work. And now the next factor, we have solvents, different type of solvents. Okay, solvents, there are two types of solvents. Two types of solvents. Okay, before we stop, I have to get your names. Okay, I got some 15 people here. So let me write the names by the, I don't know whether that, at least some 11 people are there, or 15. Number one. What are there? Dilna? Oh, I cannot see that board. That is a problem. Now just tell me your names one by one. Dilna. Dilna. Remember it. Fatima. Rinshina. Asna Harsha. Hey. I just moved.
Sir, പേര് വിളിച്ച പൗതിയായപ്പോൾ ഇതിന്റെ കണക്ഷൻ പോയി. ദിലിന്റെ പേര് മാത്രമേ ഞാൻ
I will just വേണ്ട ഞങ്ങൾ വാട്സാപ്പിൽ വിട്ടാൽ മതി പേര്. ഓക്കെ, കണക്ഷൻ കിട്ടുന്നില്ല. ഓക്കെ.